Okay, I'm gonna try to take a video here about Euler diagrams, syllogisms, and Euler diagrams. Okay, so a syllogism is like a logical argument, something like this. This is kind of the classic syllogism. All men are mortal. And then Socrates is a man. Therefore, Socrates is mortal. So what do you think? Is that a good argument? Well, when you look at it, seems like it's a good argument, assuming that Socrates is the philosopher that we learn about in Western Civ, who lived before Christ and drank the hemlock. That Socrates was certainly a man, and certainly all men are mortal. So if Socrates is one of those men, okay, then he would be mortal. So this conclusion would follow from those two premises. And we would think that this is a good argument. So these two are called the premises of the argument. And then the statement below the line is called the conclusion of the argument. And in this case, this conclusion follows from those two premises. And we would think that this is a good argument. Okay? Now let me give you another argument and see what you think. What about this? All fig trees are fish. I am a fig tree. Therefore, I am a fish. What about that? Is that a good argument? Well, when you think about this argument here, at first, this seems like probably a really bad argument. It seems almost silly here. All fig trees are fish. That doesn't make a lot of sense. And I'm certainly not a fig tree. And therefore, I'm a fish. And that conclusion isn't true either. None of this seems very good. So we might say that this is a bad argument. But when we think about it, when we look closely at these two arguments, there is a sense in which these two arguments are the same argument. They're argued in kind of the same way. This one is saying all men are mortal. Socrates is a man, therefore Socrates is mortal. This is saying all fig trees are fish. It says I'm a fig tree, therefore I am a fish. And there's a sense in which these are the kind of the same argument as far as the kind of the pattern here. This is saying all one things are another. This third thing is the one thing, so the third thing is the other thing. And this is the same thing. All one things are another. This third thing is the one thing, so it's the other thing. And so, in a sense, these are kind of the same argument. And both of these arguments are valid. So what do I mean by valid? Okay, a valid argument here is a logical argument where the conclusion follows necessarily from the premises. So now this isn't a true conclusion, but notice that this conclusion does follow from these two premises. So if it were the case that all fig trees were fish, and if I were one of those fig trees, then I would be a fish. So this conclusion follows from the premises, just in the same way that this conclusion follows from those two premises. Okay? And so we would say that both of these are valid arguments. So what's wrong with this argument here isn't that it's not that it isn't valid. Okay? What's wrong is that these premises are not true. Okay? And so the conclusion also isn't true. But this conclusion does follow from those two premises. So in a sense, this is a logical argument in that this conclusion did follow from those premises. So in a sense, I argued correctly. Okay? The conclusion followed necessarily from those premises. And we would say that it's valid. But the next section, we're going to learn that what's wrong with this argument is that it's not a sound argument. It's valid, but it's not sound. So a couple things to realize about valid arguments here. Let's say we want to note the following things. So a couple things to note here is that so the validity of an argument does not follow from the truth of its premises or conclusion. Okay? And so a couple other things is an argument may have a false conclusion and still be valid. And then I can say in parentheses, and vice versa. In other words, it could have a true conclusion and be invalid. So this is one, it has a false conclusion, but it's still valid. Let me show you one that has a true conclusion, but is invalid. Okay, let's say that all men are mortal. Let's say Socrates is a man, therefore Socrates. I meant to say here, all men are mortal. What I meant to say, this was the same argument as I did on the other page. So Socrates is, what I wanted to say here is Socrates is mortal. So all men are mortal, Socrates is mortal, therefore Socrates is a man. Okay, notice this is true. In fact, all men are mortal, that's true. Socrates is mortal, that's true. Socrates is a man, that's true. Everything seems true, but this is an invalid argument. Okay, and the reason is that this conclusion does not follow from those two premises. Okay, just because all men are mortal, Socrates is mortal, just because they're in the class of mortals doesn't necessarily mean that they are a man. Now, to see this, to clearly see this, we're going to use something called Euler diagrams. And this is how we're going to analyze logical arguments. There's a lot of different ways of analyzing logical arguments to see if they're valid or not. And Euler diagrams is one of the real basic ways that you can use to, if the argument is simple enough, you can draw a diagram that'll show that it's either valid or invalid. So what we do with an Euler diagram is we have a way of diagramming a premise. So if I have something like all men are mortal, the way that I would diagram that, I would put a box, and this is kind of, you can think of this as being your example. This is everything in your particular example. And then when you have a statement, all men are mortal, what you're going to do is put the men circle inside the mortal circle. Okay, so this circle represents all men. This circle here, the bigger circle, represents all things that are mortal. So all things that eventually die. Okay, so if you're a man, then you are mortal. You will eventually die. But there could be other things that are mortal. So there could be things outside here that are not necessarily in the min circle, like other animals or plants or bacteria. They're all mortal as well, but they're not men. Okay, so all men are mortal. So that's actually a true premise. And this is how you would diagram it. Okay, so now we can see up here what's going on. This statement says Socrates is mortal. Now, if we're thinking Socrates as the philosopher that drank the hemlock, he is a man, and we might be tempted to put him inside the men's circle. Okay? But that doesn't come from this statement. This doesn't say that he's a man. This only gives me the information that he's mortal. So I can actually put Socrates outside here. And if that's Socrates, in this case, all men are mortal. That premise is true. And Socrates is mortal. So that premise is true. But the conclusion didn't follow. He's not inside the men's circle. So there was such a way to draw this diagram here so that both premises are true in my diagram, but the conclusion is false. So in other words, that conclusion didn't follow from the premises. So this is invalid. The conclusion doesn't follow from the premises. Okay? Now you got to be careful because the conclusion is true, okay, but we're not deciding whether the conclusion's true or not. We're wanting to know if this conclusion follows from those two premises. And it doesn't follow from the two premises. So maybe another argument that might make it easier to see this would be if I have something like this, something that's maybe a little nonsensical. So all cubes are messy. Jojo is messy. Therefore, Jojo is a cube. Okay, so how would we diagram this? All cubes are messy. Let me give you a little guidance here. Whenever you have a statement that says all A's are B's, then you're always going to put the A circle inside the B circle. So to say all A's are B's means if you're inside the A circle, you're also inside the B circle. Okay? But there's room to be inside the B circle without being inside the A circle. So in other words, it's possible to be a B without being an A, because this statement doesn't say anything about that. It only tells you that all A's are B's. So when it says all cubes are messy, you're putting the cube circle inside the messy circle. So these are all the things that are messy. These are all the cubes. If you're a cube, you're messy, but there's room to be messy without being a cube. Okay? And so now we can see why this is invalid. Okay? Because Jojo is messy. All we know about Jojo is that he's messy. So I could put Jojo here. It doesn't mean he has to be there. He could be inside here and still be messy. But Jojo, according to this premise, all he has to be is inside the messy circle. So it's possible to draw my diagram here so that all cubes are messy and Jojo is messy, but he's not a cube, right? So this is an invalid argument. So in a sense, what you're trying to do when you diagram the argument, you're not trying to diagram the conclusion. What you're trying to do is set up these two premises in such a way so that both of these are true in your diagram, but the conclusion's false. If you find that it's impossible to do that, then it's a valid argument. But if you can do it, like I did here, then it's a invalid argument, okay? So let me give you an example of a valid one. Let's say I say all cubes are messy. Jojo is not messy. Therefore, Jojo is not a cube. So let's try to draw this. So this first premise is always going to kind of set up the two circles. Here's cubes. Here's things that are messy. All the cubes are messy. And then the second premise is kind of bringing in a third thing. And in this case, it's taking JoJo and it's telling us that he's not messy. So JoJo in this case has to be on the outside of the messy circle. So is there any way for JoJo to be inside the cube circle? Well, no, he cannot. So in other words, this conclusion follows. It has to follow because there's no way I can put JoJo on the outside of the messy circle and still have him on the inside of the cube circle because the cube circle is inside the messy circle. So in other words, this conclusion does follow from the premises. When I try to diagram these two, there's no way to diagram both premises and still have the conclusion not be true. So this is a valid argument. It's valid because when I diagram these two premises, the conclusion follows. It has to be that JoJo's not a cube. Because of it's kind of the physical, the way these things are set up. There's no way for JoJo to be on the outside. There's no way for him to be inside there to show that this is false because he has to be on the outside of the messy circle. That's the idea. Okay? So this is a valid argument. Same way if I have all cubes are messy and JoJo is a cube, therefore JoJo is messy, that would be a valid argument because if I have to put him inside here, he has to be on the inside of the messy circle. Okay? So let me show you one other type of kind of premise that you might see on your homework assignment. You might have something like this. No cubes are messy. And then I might have something like JoJo is a cube. Therefore, JoJo is not messy. Okay, well, what about this? This is a different first premise. Instead of all A's are B's, you have no A's are B's, or no cubes are messy. So whenever you have that premise, it's very easy. You just draw two separate circles, and these are all the things that are cubes. These are all the things that are messy. So if you're a cube, you can't be inside the messy circle. If you're messy, you can't be inside the cube circle. So it's two separate circles like that. No cubes are messy. And now what this tells us is JoJo is a cube. So there's JoJo. He's a cube. And so it follows then that JoJo is not messy. If he's inside the cube circle, he cannot be inside the messy circle. So that is a valid argument. Okay? And then I'll do one other argument like that. Let's say I have no cubes are messy. And then I have JoJo is not messy. Therefore, JoJo is a cube. Okay, so what about this? Well, in this case, no cubes are messy, so you have two separate circles. All the things that are cubes, all the things that are messy. Now notice this premise tells me that JoJo's not messy. From that, do I have to conclude that he's not a cube? No, because there's all this room on the outside that JoJo could be. Okay, he could be right here. In that case, he's not messy, and he's also not a cube. So this is an invalid argument. In other words, this conclusion did not follow from those two premises. Okay, so that would make that invalid. So all the arguments you're going to have, you're going to decide whether they're valid or invalid. And they're all going to be either all A's are B's or no A's are B's. And that first premise will set up two circles, either one circle inside the other or two separate circles. And then the second premise will bring in that third thing and put them somewhere. And then you got to decide whether this conclusion follows from those two premises. If it follows from the two premises, it's a valid argument, but if there's a way to draw your diagram so that the conclusion's not true, then it would be an invalid argument. Okay? And what we want then to do is determine which arguments actually are valid. And so math is the study of patterns, right? And so there's a pattern to the validity of an argument. Okay, certain circles have the pattern where it is valid, where that conclusion does follow from the premises. And when that is true, when that pattern holds, we say it's a valid argument, or it's logical. The person is arguing correctly. They're coming to valid conclusions, at least based upon the premises. Their conclusion follows from the premises. Okay, but when the conclusion doesn't follow from the premises, we would say that's an invalid argument. They're not arguing logically. That conclusion doesn't follow from the premises that they're using to argue for that conclusion. And so that's why logic is a branch of mathematics. Math is a science of patterns. There's patterns in our reasoning, and certain patterns lead to valid conclusions, other ones lead to invalid conclusions.